Ladies and gentlemen, welcome to Wolverine Crypto Trading's final event for the 2018 winter school year. Really appreciate you all showing up. And with Bitcoin around $7,000, we have a much smaller attendance than we did when we did a crash course on cryptocurrencies, where we had over 400 people pack this auditorium. So to all of you in the audience today, thank you for coming. We're going to be leading off today with talking about what our organization is, and if you want to check us out, it's some of the young folks over here. We're going to be talking about Blockchain 101, where I'm going to go through about a 5-minute overview of the blockchain technology. We're then going to dive into 5 applications of blockchain and look at specific projects, none of which have been endorsed by the projects, but instead are picked by our students, of interesting things that are going on in the space today. And then Rishi will close us off with challenges and drawbacks of blockchain. And for all the haters, which I don't think there may be many in this room, that might be your favorite section. Now we're going to start off with a quick video from the Wolverine Crypto Trading team to explain who we are. Blockchain, Bitcoin, decentralized applications. These are esoteric terms that we hear so often but know so little about. These ideas that are too big for one person to tackle are the reason why we created Wolverine Crypto Trading.
Wolverine Crypto Trading is the first student-led cryptocurrency investment fund in the world. Founded in 2017, our focus is on education around cryptocurrencies and blockchain technology for university students.
A highlight of my week is our discussions that consist of 2 parts. An educational presentation, and a book club-style dialogue. Topics can range from using debit cards backed by crypto, a blockchain-based internet browser that protects your personal data, and how to create a new cryptocurrency from scratch.
They say you really don't learn or know something until you've had to teach it to others. And by alternating between student and teacher roles, well, that really enables us to dive deep and truly understand complex technologies. I had to push myself to understand new and technical concepts and reiterate them to the team in an easily digestible format.
In an open forum, we wrestled with questions I never would have thought of. For example, the future of the shared economy without intermediaries. Imagine directly connecting drivers and riders without Uber. Combining engineers and business majors in one room has opened my eyes to assess the technology from a whole new perspective.
One of our core initiatives at Wolverine Crypto Trading is to educate the broader University of Michigan community. We do this through having monthly meetings that we call town halls. During these meetings, the team explains complex technologies in an easy-to-understand way.
One of the things I love the most about Wolverine Crypto is our community events. Our first town hall included Ross School of Business professor Andrew Wu, whose FinTech Innovations course covers emerging tech such as how businesses are implementing blockchain. Next, we hosted a crash course on cryptocurrencies, where we brought 400 students up to speed on the similarities and differences among the most popular cryptos.
I didn't anticipate the friendships that blossomed from this organization. My favorite part was when our team went to the largest cryptocurrency conference in the world in Miami, Florida. Our travels glued us together as we socialized with thousands of cryptocurrency enthusiasts.
Everyone on the team is intellectually curious. We start by talking about crypto, but that evolves into a dialogue on why society is the way it is, and what technology may or may not influence.
We believe that innovation is best achieved through collaboration. The overwhelming interest from Michigan alumni has been encouraging. Looking forward, we're thrilled to establish the University of Michigan as a thought leader in financial innovation.
From all of us at the Wolverine Crypto Trading team, we'd like to thank the University of Michigan, the Ross School of Business, and the Zell Lurie Institute for Entrepreneurial Studies. Without your support, this wouldn't be possible. We look forward to the challenges that lie ahead. Now to continue with more of the fun stuff. Let's get back to blockchain. The origin of blockchain actually takes us back to 1991. This is something that I did not know until just recently researching for this presentation. The first talks of blockchain technology, which was piecing together existing infrastructure. So not all of what blockchain is brand new. Instead, what it is piecing together puzzle pieces that previously existed in a different way than ever had been done before. And the first time that was done was in 1991, where 2 researchers said, hey, We can digitally timestamp things like contracts and photos and other sorts of data so that they can't be changed in the future, like many of us know what a notary is today. What is blockchain? We're going to break this down. Let's start with it's a shared ledger. What that means is that no one person or entity holds the list of transactions. Instead, blockchain is shared, and anyone in a public blockchain, anyone that would like to, can become a node and can become a member that can go and download the list of all transactions in the entire history. It's a shared ledger for recording the history of transactions. Again, we're getting back to the thought of transactions. Blockchain is built for transfer of value. It cannot be altered. We have heard that it's secure, blockchain. In reality, it's really not secure. Instead, it is inimitable. You cannot change the blockchain in the future. But unlike your, I'm going to pick on JP Morgan for a second. Your JP Morgan account, when you log in, you have a username and password. And you're responsible for holding on to that password, not letting anyone else get it. If someone else gets your password and tries to log in, there's protection where JP Morgan could say, hey, we shouldn't let them in. We don't think it's you. With the blockchain protocols that we're dealing with today, that does not exist. So when we say secure, people are really bad at keeping secrets. And for that reason, blockchain is not secure. But it can't be changed. On an individual level, it's very easy for a user to lose their, what we call a private key, or their password, to access their value. Let's talk about how we actually build a block within the blockchain. So here we're going to use a visual to show the blue is a block. And within that block, there are going to be a series of transactions. So they'll be from person A to person B for amount X. That's each transaction has those 3 points of data. We then aggregate those, and each of those smaller are figures in the diagram is a transaction. And when we take, let's say, 20 transactions and put them together, we get a block. We then can take those blocks, which are, for this example, a series of 20 transactions, and we can link them. And we can have one reference the next and reference the next. This makes it secure. How do we connect the blocks? So I described that we connect to previous blocks, but how does that actually work? And the answer is through hashing. Can you raise your hand in the audience if you're familiar with the term hashing? All right, so about 25% of our audience. It's like a digital fingerprint for data. So you can put in an image, you can put in text, you can put in the Library of Congress. And the output is what's called a hash sum. So in this example, we put in the text, which is data of Fox. We then run it by a hash function, and we get a hash sum, which is fixed length. So no matter how much input, in this example, you're going to get a fixed length. Well, what if we change that Fox? And let's say we add some words to it. The red fox runs across the ice. We run that by the hash function, and we get a different hash sum. Same length, because it's fixed length, but totally random. You can't go from the hash sum and get back to the input. If we then change the word runs to walks, again, we get an entirely different hash. Can I get from 1 to 5, 5 being I totally understand this. How are we doing in the audience? 1 to 5, throw up your hands. All right, it looks like we're averaging over 3. So for right now, we'll move on. Now let's take the same concept that we just learned of you can take any amount of data, put it through a function, and get a fixed length output. Let's take that and apply it to the blocks that we talked about before, and the block is a series of transactions. So in this case, we have block number 1 with hash 1Z8F. When we create a second block, so we're going to close out that first series of transactions, in this example, when we get to 20, and we're going to move to the second block. We then start the second block with the hash of the previous block. So in this case, that 1Z8F is going to be at the very top, and then we're going to put below it a list of all the transactions that happened within that time frame. We are then going to lock that block, hash it, which gives us a fixed output. In this example, 6BQ1. And when we start the next block, block number 3, we're going to start with that hash. Then we're going to put the series of transactions, and we're going to do it again. This is what a blockchain is. Okay, the explanation of the technical is fun, but where does the value get generated? We are in a business school, so let's talk about some of the value generation. On the bottom here, the blue, is what's called a protocol layer. If you are familiar with HTTP, which hopefully you see daily on your browser, TCP or IP, these are all open source protocols that were developed for the internet stack that we use today. These captured very little value. Those that created the concepts of these HTTP, TCP, and IP actually didn't get that much monetary reward. However, the application layers, which we're familiar with, so think of anything built on top of the internet, like Facebook, Amazon, Netflix, and Google, were able to get billions of dollars of value. So the base layer, the protocols, didn't get much value, but the application layer captured lots of value. With blockchain, the protocols capture value instead. So we see the orange now grow much bigger, and that's the protocol layer. Protocols capture the majority of the value, while companies only capture a sliver. Bitcoin is currently worth $115 billion, the largest protocol that is blockchain. And with that, we can see that the biggest company in the blockchain space, which is Coinbase, is worth just a few billion. In comparison, we've seen a flip. Before, it was the application layers, and now it is the protocol layers that are creating and capturing value. Let's look at some real examples of projects that are happening in the blockchain space to understand specifically where that value is being created and captured. And to do so, I'm proud to invite the first group of the Wolverine crypto trading team to talk about blockchain and banking. Thank you.
Thank you, Danny. Just to get started, my name is Rama. This is Matt. We're going to be talking about applications of blockchain and banking. So a couple quick agenda items. We're first going to be talking about processing payments and how we can eliminate the need to rely on intermediaries. And then next, we're going to be talking about clearing and settlement and how we can reduce operational costs. So imagine a scenario where I'm stuck in Managua, Nicaragua, without any financial resources, an iPhone, no technology.
I'm Rama's friend. My friend Rama is stuck in Nicaragua. What do? I'm going to send him $1,000 to make sure that he has enough money to get on a flight, hop back, and get back home safely to Ann Arbor. He doesn't have a bank account in Nicaragua, though, so he has to go to the local government, create one, so that I can pull out my Bank of America app and send him $1,000 via a wire transfer. Nicaragua is a long ways away, so we're not going to want to drive. I'm not going to want to fly and pick him up. It's just not the most efficient thing to do. So what we want to do here is just do that wire transfer, and we're going to looking forward. We're going to see how we can make that more efficient.
So now that I know Matt Policy is going to send me $1,000 through wire transfer, I realize that it's actually going to take about 3 to 5 days to process this transaction. In fact, for the money to get from Detroit to Managua, there may be a lot of different segments of time that will be subtracted through, such as fraud reduction, bank mistakes, or slow-to-pay countries. Additionally, I'm not actually going to receive $1,000. In fact, on average, about 7.68% of the $1,000 is going to be taken away through fees. This can be split up by first upfront costs, such as the wire fee, that could be $25, as well as hidden costs, such as the exchange rate fees, through many different intermediaries. In fact, if Matt Policy were to instead send money through Western Union, a service that specializes in cross-border payments, $81 out of the entire $1,000 would be taken away. Instead, if these banks were to implement blockchain, both myself and Matt Policy would benefit significantly.
Yeah, so there's going to be a lot of blockchain solutions moving into the future on this sort of subject, but let's just talk about Ripple for now. That's one of the main things that's happening in this space, and it's trying to revolutionize global payments. They're a private company with their own private blockchain that's really revolutionizing this space. So if you look at our situation right now, we're in an international scenario where I need to send money to Rama. He needs that money, and typically we're going to send that through many different countries and many different currencies, and there's a lot of middlemen and a lot of intermediaries that are going to take a slice of the pie along the way. So what Ripple's trying to do is jump right in the middle, take away that need for middlemen, and just from one country to the next, just an easier and smoother process. Right now, the costs are about 5 to 20% per transaction, and it takes about 3 to 5 days for it to happen. If we implement a blockchain solution such as Ripple or, say, another cryptocurrency or another blockchain solution, we could take the cost down to 2 to 3%, and the time it takes about 3 to 5 hours. For Ripple, on a per transaction basis, we're saving about 60%, so that's a lot. And we know that a lot of this is coming from payment processing, as you can see behind me, so it's a really efficient solution.
As for the market size of this issue, it's about $1.6 trillion annually that is spent on the cost of processing global transactions. In fact, if a company like Ripple is able to harness their technology to reduce this cost, both myself and Matt Balsey would benefit in our situations with decreased costs. Now moving on to clearance and settlement. So clearance and settlement can be broken down into 3 different parts. First is execution, where the buyer and the seller legally bind themselves to a different agreement. Next is clearing, where all the steps, and these are all the steps leading to the settlement. This can be recording the transaction or processing the transaction. And then finally is the settlement itself, which is the actual exchange of assets or goods. Right now, a lot of financial intermediaries, such as banks and insurance companies, use the network called SWIFT. And this SWIFT network is a financial messaging platform that allows different banks to interact with each other. Now, one of the biggest problems with clearance and settlement right now using the SWIFT network and other infrastructure is settlement risk, or the risk of a company defaulting or reneging on an agreement. Additionally, on average, this settlement time is about 3 days using the SWIFT network. And finally, this leads to a cost efficiency of about $65 to $80 billion every year.
So for clearance and settlement, what's the blockchain solution right now? Right now, R3 has proposed a solution. What it's trying to do is it's a consortium of companies trying to implement blockchain into the financial services industry. And a lot of companies, big name companies that you know and love, like Microsoft or KPMG, show that this ranges from technology companies to accounting firms. So really a lot of different companies and a wide breadth of companies are joining in on this consortium to help change blockchain. For example, the R3, what they're providing is called Corda. It's a software open source platform that allows business-to-business transactions using smart contracts. And if you don't know what a smart contract is, just on a high level, pretty much it's a contract coded on top of the blockchain that allows transactions to occur once a set agreement is come to, in a way. So what that allows for clearance and settlement is quicker settlement, a very instant process throughout this whole thing, and also contract and regulatory control. So behind me is a graphic of, say, me and Rama's situation. Say Rama's bank in Nicaragua and my bank in the U.S. are both part of this R3 Corda network. We're able to transact our assets or securities throughout each other while being in this network and being overlooked by a process that made sure every single transaction is correct. And a lot of the advantages are similar to earlier in the presentation. It's cost efficient, it's time efficient, and it's really transparent. And overall, we're going to get Rama home. The blockchain is the most efficient solution that we've come up with, and it's really interesting to look at, so I hope you guys learned.
Great. So now I'm going to pass it on to Ali to talk a little bit about blockchain in healthcare.
All right. Thanks, Matt and Rama. That was awesome. My name's Ali, and I'm going to be presenting on the applications of blockchain in healthcare. So I hope to be, in the medical industry at some point, but right now I thought it would be best to learn about the problems in the healthcare system by talking with the doctor who works here. So I met with Dr. Matt Sagakis, who is the lead anesthesiologist in the University of Michigan Health System. And I spoke with him about what he sees as the biggest issues in healthcare right now, especially from his day-to-day operations. And what he told me can really best be conveyed through a story of a guy named Todd. So this is a made-up story. So imagine Todd is a middle-aged man from northern Michigan who comes down to Ann Arbor to watch one of the basketball games. But due to our basketball team, he experiences a heart attack while watching the game. And so now he's rushed to the hospital by his daughter. Now, when they arrive at the hospital in the emergency room, the nurses are trying to get all his personal and health information. But his daughter has to speak for Todd because he can't speak right now. He has a heart attack. So she doesn't really know all the information, and so they have to call his main provider in northern Michigan. However, this call can take anywhere up to 20 to 25 minutes depending on, who's staffed at that hospital. And so the doctors make a split decision and rush him in and begin operating on him. So standard, you have to have their information before you begin the operation, but since the doctors couldn't get a hold of his information, they begin the operation and they proceed to insert an airway tube into Todd. However, he has an adverse reaction and the operation takes a turn for the worst. So unfortunately, this is actually more common than you might think. Nearly 440,000 deaths occur each year just from the sheer fact that patients and doctors don't get to share their records with clarity. And this leads to about $18.6 billion in annual costs, just sheer from interoperability, which means that hospitals can't really communicate with each other and share records fluidly. So with the Northern Michigan Hospital and the hospital here on campus, the fact that they can't share records leads to these types of costs that you see here. And so with a blockchain solution, where it would really play in is by connecting Todd and the data that belongs to him, his personal healthcare information. That's kind of where a solution exists. So a really notable solution right now in the space is MedRec. MedRec is trying to connect patients with their personal healthcare information through a platform built on Ethereum smart contract. And it's being funded by the MIT Media Lab, and the proof of concept is being tested in the Harvard medical system. Essentially, MedRec is trying to enable patients to have the private code that they can use to access all their healthcare information, and essentially it would cut out the provider from, or depending on the provider, to contact other providers to get information. So in standard practice, this is kind of what it looks like. This plain graphic here just shows it, because the provider basically goes to the other provider to pass on patient information. And the patient really doesn't have any bearing on this. They can't control it. And with that situation with Todd, he couldn't really control how fast the Northern Michigan Hospital could get his information to the hospital here. So with a solution with blockchain, especially with MedRec, what that would look like is the patient now controls their own information, and now they authorize their provider to access it with whatever application that MedRec ends up becoming. So it could be an application right on your phone. And so the patient now enables this provider to access all their information, and any new records that need to be added on, they go right back to the patient. And so the patient authorizes the provider to add more information to their records. So this enables patients to kind of maintain they basically understand the evolution of their data, and there's never a moment where they're unsure of what the doctors put down about what operation they had. And so tying this back in with Todd, if he were to go back to the hospital and the situation occurred and he had MedRec as a solution, his data would be linked right to him, and they wouldn't have to worry about contacting that doctor in Northern Michigan, and the doctors could proceed with this operation very quickly. So some of the benefits that result from using a solution like this. This is actually one of my favorite elements of this, and it's that the researchers are incentivized to mine that patient data blockchain. And basically, if anyone's familiar with how blockchains work, the mining is what allows the blockchain to progress. And so in a case like this, researchers are going to mine this blockchain and gain access to aggregated patient data, which they can use to better understand health at a macro level and test whatever hypotheses they're trying to do in their research with this data. And at the same time, they can maintain anonymous personal, the blockchain will maintain anonymity with the patient health data. And this is just because of the nature and the way it's stored on the chain. And if I had a lot more time, I would definitely get into some of these other options that blockchain could definitely be used to solve in the healthcare field. My favorite right here is the drug supply chain management, and that could, blockchain could be used to enable doctors to control how much or monitor how much of the opioids or whatever illicit substances are being passed out in different clinics. But essentially, there's a lot of issues in healthcare, and by exploring blockchain, we can definitely get closer to making that industry more efficient. Thank you.
Hey, Karan, how's it going?
Pretty good, Akshay. How are you doing?
I'm doing well. Just learned about blockchain and some of its applications.
That's cool. Have you learned about how blockchain can be used in the supply chain?
Only a bit, but I think I need to learn more.
Sure. So let me give you some background. The food that you buy at a grocery store, the clothes that you're wearing, and almost any other product that you can think of was carried through a supply chain. A supply chain is simply the process of moving products from the producer through a series of checkpoints until it ultimately reaches the consumer. So the supply chain industry itself is a multi-trillion-dollar industry and spans across multiple industries like agriculture, technology, and healthcare. While also spanning across multiple industries, the supply chains can also span across different jurisdictions, which makes governing them a unique difficulty. Now, while our products have seen many innovations in recent decades, the supply chain hasn't seen this type of innovation. The main problem here is that consumers and companies know where their products are coming from and where they end up, but the process in between is largely unknown. Let's take Chipotle for an example. A few years ago, they had a major E. coli outbreak, which affected hundreds. Now, Chipotle boasts that they source their ingredients locally and naturally, but ironically, this was also the cause of their problems. When it came time to pinpoint the origin of the outbreak, they were unable to do so and were therefore also unable to predict where the outbreak would spread. And this is a huge problem.
Yeah, I definitely agree. And I think the Chipotle example is remarkable because it shows you how complex and big these supply chains can get for these big organizations, and that problem's only going to exacerbate. With the rising population that we have. Our global population is expected to exceed 10 billion in the next decade, and with e-commerce and economic growth pacing that, I think these big companies are going to need better technological solutions to make sure that they can handle what their supply chain is throwing at them. And two of the big issues that supply chains face are that they have a lot of parties, and these parties have to go through trust, and they also have to make sure that they're able to have verification of all the processes that are happening within the supply chain. So I think by instituting technologies like blockchain, you'll really be able to make sure that all these parties are on one synchronized ledger so that they can see what's happening and they can all see what's happening amongst every stage of the supply chain. So this is going to make sure that many issues that are present in supply chains, such as product recalls, faulty products, or even more on a higher level, such as corruption, can be exposed earlier on as opposed to bigger problems that Chipotle faced.
So actually, I know you have some experience in the jewelry industry. Do you think that supply chain can be used in that industry?
Yeah, I definitely think it can, and I was going to talk about that. So to speak about the jewelry industry quickly as a whole, the jewelry industry is massive, and one subset of that is the diamond industry. So within diamonds, right, the way it works is that the supply chain kind of looks like this. So from the point of its mining inception, diamonds are going through so many different parties. They go through traders, they go through cutters, they go through polishers, and then they go to a jewelry manufacturing facility site. And over here, the diamond gets placed in whatever type of jewelry that you want, and then it goes through a wholesaler and retailer, and finally it ends up in the consumer realm, which is traded multiple times over and over again. And since and you see that this is such a convoluted supply chain, there are a lot of places where these diamonds can get lost, where they can get smuggled for tax evasion or smuggling purposes, or where they can also just be tampered with and replaced with synthetic diamonds, which are fake diamonds, or conflict diamonds, which are completely outlawed in the industry. And the reason why this is important, reason why this can kind of really benefit from blockchain is that every year, annually, $45 billion is lost in insurance fraud for jewelry. And that number is even higher when you take into account tax evasion purposes, because diamonds, before Bitcoin, were a great way to move around money. And so I would say that companies like Everledger, which is a company that specializes in blockchain technologies for valuables, have specialized products out there, and they've actually registered 2 million diamonds, approximately 2 million diamonds, on their blockchain. And the cool part about it is that these diamonds are tracked in every process of the supply chain, from mining to cutting to polishing, and the way they do it is from a two-step process. So first, they actually take pictures of these diamonds after every part of the supply chain. So suppose that the diamond has just been mined, they'll take a picture of the rough diamond. Then they'll take a picture after it's been cut, after it's been polished, after it's been put in a jewelry piece, and they're going to be able to cross-reference that picture with each other to make sure that this diamond more or less looks the same. However, they're not going to just rely on visuals. You're going to also cross-reference it with points of certification and authenticity. And over here, that comes through the form of the Kimberley process certifications or GI certifications. So this kind of gives them a two-pronged approach to make sure that the jewelry that they're selling or the jewelry that consumers are buying is exactly what they're paying for.
That's pretty interesting to hear. So another industry that the blockchain can be used in its supply chain is the seafood industry. With tuna specifically, 5 out of 7 species are endangered. These fish are also migratory, and what that means is that they can be caught anywhere in the world and therefore fall under multiple jurisdictions. On top of all this, 20% of all tuna entering markets are caught illegally or in some unsavory manner. So this provides blockchain with the opportunity to provide more transparency into the supply chain and therefore encourage more ethical catch procedures. So let's imagine that you're a restaurant owner and you want to serve tuna in your restaurant. The way a blockchain can help with this is a product called Hyperledger Sawtooth. The way this works is just after the fish are caught, they're tagged with IoT sensors, which continuously track metrics like temperature, time, and location. As the fish move through the supply chain and exchange hands, all of these transactions are recorded on the blockchain. So when you as a restaurant owner receive a shipment of fish, you can know exactly where they came from and if they were ethically sourced or not before they enter a customer's plate.
I think that's really neat because it shows you that blockchain not only today is revolutionizing different industries, but it will continue to do so tomorrow, whether that's commodity products like tuna or more luxurious items, like diamonds.
Yeah, so this was a great conversation, Akshay. Here are just a few companies that are using blockchain in supply chain applications today. Feel free to talk to us about any of them afterwards. Thank you.
Hi everyone, my name is Derek. This is Isaac. Hi. And we're both pretty deep into the technology part of blockchain. So today we're going to give you a presentation on how do you use blockchain to fight back internet censorship. So just first let me tell you some backstory about myself. 2 years ago I was doing an international internship, actually back in my home country. And I need to access the university's email service because I have to register for class. But however, I cannot access the service because University of Michigan's email is actually managed by Google. And Google is not that accessible when I was home. And so that's how I initially got interested in the topic of internet censorship. Because I saw the internet was free and open, anybody can just access any of the resources hosted on the internet. So how exactly do you stop somebody from accessing such material from a tactical perspective? So I went into some research of how it works. And if you're going to take a proper networking class, and this is how you're going to learn. You're going to learn every single node in this graph, what does it do, and how is the information passed from your own PC to the server, and what are some of the points of failures in this process. But today, I'm just going to use an analogy of how this works. So I would say passing information on internet is like passing a love note, passing a love letter. And so just for an example, why are these two situations similar? They're similar because you want to make sure the information gets to the correct destination. It doesn't get lost during the process. And how is that note being delivered, right? So suppose you want to send a note to Alice, but you and Alice, you don't go to the same school. You had to find an intermediary, her sister, Eve. And so you're going to give your note to Eve, and then Eve is going to pass the note to Alice. Works fine, as long as Eve is cooperative. So what if Eve really hates you, right? You give your note to Eve, she says, okay, I will pass the note. Then she just throw this note to the trash can. You have no way to tell. Like, you don't know if Alice got the note or not. So what's the solution? You ask another guy, Bob. So you give your note to Bob, and Bob gives the note to Eve. Eve has no idea that this note originally comes from you. So she's going to pass the note to Alice. And now it works. So why is this relevant to the internet censorship case? So in the internet anti-censorship scenario, who is this intermediary? Who is Bob? So at current moment, two of the most widely used solutions are Tor network and VPN, virtual private network. So Tor is a decentralized solution, and VPN is more of a centralized solution. And Isaac is going to further explain to you what are them.
So in the case of the Tor network, why is the service being offered? Basically, volunteers on the network will route your information around the internet to the destination so that the people in the network can't see where the information is going. In the case of a VPN, you pay a VPN to do this for you. So what's the problem with the VPN? Well, in a centralized model, if the government says to the VPN, stop sending my information to google.com, they just kill the VPN and then I can't get on the internet. But in the case of the Tor network, since it's a volunteer basis, a volunteer could hypothetically set up a bunch of nodes and basically overtake the network because there's no economic disincentive for them to do so. So we can use blockchain to solve this problem. And I'm going to go over two examples, the Orchid network and Skycoin. So in the case of the Orchid network, it basically takes the Tor network and then adds an economic incentive to it. So it's a decentralized market where you can buy and sell bandwidth. So the buyer will provide Orchid market tokens to a seller who will then provide bandwidth to the user. So it'll look as if I'm going through a seller who's then going to google.com, so the government can't tell that I'm going to that website. And in the case of Skycoin, they actually took this a step further. So they designed this hardware on the right, which basically replaces the internet backbone. So in the world, there's about 8 or 9 servers that control all of the internet routing throughout the entire world. And see, that's a big problem because it's a centralized model, basically. So Skycoin wanted to decentralize this, so they produced these miners, basically, that sit at home in your room and can route people all over the internet. So it basically turns these 8 internet backbones into thousands and thousands of nodes across the internet. And just like before with Orchid Market, the nodes are paid in Skycoin to basically do this. So it gives them some economic incentive to be honest. So a little bit of an overview about internet censorship. We have the Tor network, which has the problem of being just on a volunteer basis, so there's no economic incentive to be honest. And then you have the VPN, which is centralized, so there is an economic incentive, but it's centralized, so it can be killed easily. So how do you solve this? You add a distributed ledger or a blockchain, basically, which will keep nodes honest. And you basically set up smart contracts between the users and the sellers. And so I'll pay somebody with tokens, and if they don't give me bandwidth, the network will say, wow, you didn't give this person bandwidth. Okay, I'm going to take away all of your money. And if I don't use my internet service properly and I don't pay the person for the bandwidth, then I won't get the bandwidth. So these 3 things together will create a more secure and anonymous internet. And that's about it for blockchain on the internet. And then I'm going to pass it off to Andy and Justin to talk about digital identity.
Thanks, Isaac. Hey guys, I'm Andy and this is Justin, and we're going to talk about digital identity on the blockchain. Real quick, just want to mention the last application-based project that we're going to be talking about, then we're going to wrap it up a bit. All right. So today we're going to be talking about 2 problems in the space. The first is giving an identity to those who don't have one, and the second is taking back control of your data from big companies who own it right now. We'll start off with that first problem. So in June of 2016, roughly 80% of refugees who were trying to seek asylum in Germany were turned down for one reason. And that was because they did not have proper documentation. They didn't have a passport, something that we see as what is your identity. And that proves your identity to the government. And that's a huge issue for people seeking refuge all over the world. But not only them, there's actually 1.5 billion people all over the world without a recognized identity. 20% of the world is completely unknown. They have no form of identification. And when you don't have any form of identification, you don't have any access to basic services like a bank, access to education, access to healthcare, a job, being able to vote. Imagine going to a bank and you go and apply for a loan and you say,
okay, here, can I have a loan? They say, what's your name? What's your date of birth? What's your social security? And your response is, I don't have one. I don't know. Doesn't really work.
So one organization working to solve this is called ID 2020. They're partnered with Microsoft, Accenture, the Bill and Melinda Gates Foundation, among many other partners. Justin and I recently had the opportunity to speak with John Edge, the co-founder of ID 2020. He told us that he thinks everyone should have agency over their own identity. What does this mean? That means that everyone should have an identity of their own that they have control over. John told us that in order to see this vision through, ID 2020 needed to create identities that were three things: private, portable, and persistent. Using blockchain technology, they're working to fulfill all of these things. First off, private. That means that you can use your fingerprint or a face scan to be able to access your identity so that only you can access it. Second is portable. Blockchains are decentralized, which makes portability very easy. No matter where you are around the world, as long as you have internet access, you can access your identity and all of your information. And then persistent. Blockchains are immutable ledgers. This means that no one can go back and change it. Once your identity is on the blockchain, it's there to stay.
So I just want to give you guys a run-through of an example, something that actually happened with ID 2020, a project they've been working on with Syrian refugees. Imagine you're in Syria, you have your kids, and all of a sudden you're in a war zone, and you have to leave. You grab all that you can. Sometimes you grab your identification if you have, sometimes you don't. And you go to the closest refuge center, which is in Jordan. Right now there's 5 million Syrian refugees who went to Jordan. First step, you go to the refugee camp and they take your biometrics and they take down all of your data, everything about you, where you came from, who you are, your kids, and they put that onto the blockchain and they use your biometrics so that you are the only ones who can access that data to prove who you are to other people. Why is that useful? Well, these people, when they arrive at the refugee camps, they don't have a lot of money. Usually they have no money. They have no access to food. They have no access to water. How are they going to live? The UN provides a lot of these basic amenities for them. They provide you with water, food, stamps, access to financials, and a way that they've been doing this now is that you go to the grocery store, you scan your fingerprint, or you have an iris scan for your eyes. And they can verify that you have been verified by the UN to receive funding for food. Or you can go to an ATM and you can put your fingerprint down, you can receive a monthly allowance from the UN. And there's actually been 50 million transactions, $50 million worth of transactions in this one refugee camp in Jordan. And there's 27 million refugees all over the world. So imagine how big of a scale this could be. But now to talk about something that's a little bit more applicable for us, taking control of your data. Your digital footprint, the data that you have, is your identity. And what do I mean by that? Well, let's pick on someone in the crowd. One of my friends, Danny, he just came up and spoke to us. I want to show how all of his data that we can find just off of public websites, what it is and how it defines him. Well, we actually know based off of his Facebook that he's going to work at Amazon. It's pretty cool. He's studying at the Ross School of Business. He lives in Ann Arbor. He's from Beechwood. And he's dating Katie Zetzman. Is she here? Oh. Uh-oh. What other data can we find? Well, there's a whole wealth of data you can find online about Danny. In fact, I even know that when he goes on Yelp, he reviews restaurants, then he reviews food, then he goes to nightlife, and then beauty and spa. There's so much information. I didn't know you like Dram. That's pretty cool. There's so much information online that you can find from someone, and it really shows that this is your identity. This is who you are. This is who Danny is. And the fact that all this data online is kind of scary.
So we know that this digital footprint makes up your identity. But who owns it? Private companies own your digital identity. Facebook owns all of this data that you share. It's not yours, it's theirs. We hear all the time about how Facebook's selling this data, and even in the news now, how it's influencing political elections, your data. So, there's opportunities with blockchain to change this narrative. What if you owned your own data? If it were decentralized, these big companies wouldn't own it, it would be in your hands. Now an interesting opportunity comes, rather than Facebook selling your data, you could sell it yourself. How much is your profile picture worth? Or your Facebook About Me page? All of this stuff would be in your hands. You could choose who's able to buy it, and you would make the money rather than a large company like Facebook. Another opportunity that arises when you own your data is the ability to unsilo. So currently, siloed data is your Facebook activity. It's owned by Facebook. They have that. Twitter, owned by Twitter, so on and so forth. When you own your data, suddenly you can have it interact. Your digital footprint can be used alongside machine learning to make predictions that actually improve your internet experience. Imagine using your Facebook likes combined with your Twitter activity to be able to find a workplace that would suit your needs best on LinkedIn. Or for those of you who recognize that logo all the way on the right, imagine using your Spotify listening history to get better matches on Tinder. The opportunities are endless.
So let's focus on an application right now that's actually putting this into real work, Blockstack. Blockstack is a decentralized internet, and what does that mean? Well, right now we're all familiar with the internet. Danny kind of explained there's that protocol layer that no one really knows about and understands, but then on top of that there's an entire layer of applications, Facebook, Google, Amazon, all these companies that built on top of it, and you have all of these new applications. Well, what Blockstack does is they enable you to build applications on their web browser, on their Google Chrome, for example, or their Safari. And when you build these applications, like a Facebook or Google, all of the data that you have about you, your search history, your friends, it's all yours. It's revolutionary. Everything that you do on this browser is your data. You can sell it, you can not sell it, you can do whatever you want with it. And the crazy thing is that right now, you can go online. There's 70,000 developments that are being created right now. They have $52 million in funding from their ICO, $5 million from people who believe in them, like incredible venture capital companies like Y Combinator and Union Square Ventures. So you can really see that this is becoming a new revolution of your digital identity and a place where you can store your data. Just to wrap up and kind of tell you a little bit what we were just talking about, there's a lot. 2 applications of digital identity on the blockchain. They're not all of them, just 2. ID 2020, working on making an identity a basic human right and making sure that your identity is portable, it's digital, and that it's with you wherever you go. Another thing is Blockstack, where you can take control of your data. Same thing, it's data ownership. But in this sense, you're taking it out of the hands of the big companies, and you're taking it into your own hands. And that's all we have right now in digital identity. We're going to pass it off to Rishi to kind of recap on some skepticism of blockchain and the downfalls. Thank you.
Hey everybody, my name is Rishi. Like Justin mentioned, I'll be talking about some of the shortcomings of blockchain. So it's become fashionable to say these days that I like the technology but think that Bitcoin is nothing more than a speculative asset that will go to $0. How many people have heard something similar to that? And I find that really interesting because not only would we not have the technology if it wasn't for Bitcoin, Bitcoin is also the best known and earliest implementation of the technology. And due to the size of its network and the number of its participants, it's also the most efficient form of decentralization. That being said, it's not all that clear yet how useful decentralization is relative to traditional software for most people. The CEO of Chain.com, Adam Ludwin, put it nicely by saying, simply put, you cannot argue that for everybody, Bitcoin is better than PayPal or MasterCard or Visa as a payment system, or for everybody, Filecoin is better than Dropbox for file storage. The reality is that there are structural trade-offs that exist from the decentralization that Danny explained at the beginning, and these can't be solved, some of them, by some of the technical solutions that you're hearing these days. And to be clear, you don't need to understand these trade-offs and these challenges to speculate on or trade crypto assets. But given that decentralization is such a commonly misunderstood concept, I thought it would be helpful to speak about some, not all, of the reasons why we have yet to see a massive-scale consumer enterprise application that leverages this technology. So first off, storage. So the whole point of a decentralized database is that every participating node on the network is expected to keep an actual copy of the database. And with an increasing number of transactions, the size of this database is infinitely increasing. Moreover, the transactions are stored forever on the ledger, since this database is append-only and immutable in nature. So the question here is, how is every node expected to store an infinitely accumulating amount of data? Take Ethereum, for example. If you wanted to run an Ethereum node, the Ethereum blockchain is growing at a rate of 60 gigabytes per year. Compare that to Bitcoin's 55 gigabytes per year, and that represents an immense barrier to entry. So you should also be aware of the security threats from other entities. Much like cryptocurrencies and blockchain technology, the era of quantum computing is coming of age. Now you might be asking, what is quantum computing? How is that different from traditional computers? And what does that do with cryptocurrencies? So, glad you asked. Quantum computers use quantum bits, or qubits, to store information, whereas traditional computers use binary bits to store information. So in traditional computers, their data points are either at a value of 0 or 1 due to the binary nature of their values. But in the quantum computer, data points have a superposition of states. That is, multiple states at the same time, multiple values at the same time. So for example, this allows quantum computers to store massive amounts of information at a fraction of the cost. And it's even said that some quantum processors are up to 100 million times faster than traditional computers. So to put that simply in an example and to sort of oversimplify it, if a traditional computer can guess 1 number per second, a quantum computer can guess 100 million numbers per second. And for those of you who are familiar with the public and private key cryptography that's used to secure many of these crypto asset networks, then exploiting someone's private key, given just their public key, is altogether exploitable and feasible. So this is a flashy headline, but did you know that a single Bitcoin transaction uses enough energy to power 27 homes for an entire day? And that number is increasing every single day. And that has to do with how Bitcoin transactions are secured and verified on the network. And without going into too much detail of the different consensus methods, Bitcoin uses a proof-of-work consensus method. And proof-of-work is basically a mechanism that places some restrictions on who can log transactions on the network. So in Bitcoin's example, the miners who are responsible for maintaining that ledger must contribute some resource-intensive work, in this case time and computational power, to verify transactions on the ledger. Now, as more and more Bitcoins are mined, and the mathematical problem that these miners are racing to solve in order to verify these transactions gets tougher, this is going to require more and more computational power and energy to solve those math problems. So none of this is to say that this list is comprehensive, and yes, there are developers who are actively working on solutions for many of these problems. And this is very important. The point isn't that blockchain technology isn't meaningful or useful or innovative technology, just that the current state of applications aren't worth even a fraction of the valuations that they're being priced at today. Now, while this technology may be useful, it's important to remember that decentralization is not some silver bullet that's going to solve every single problem of centralization that we have on the internet. That being said, the problems that we have today may not be the same problems that we have 5 to 10 years from now. And we have an active global development community who's really excited about a new technology, a new data structure, and a new way of transacting value between two individuals. So why not go along for the ride? All right, so I'm going to wrap it up now. It's been an incredible ride this year. This is our last event for Wolverine Crypto Trading, being able to engage with such intellectually curious students, both you guys in the audience as well as our fund members here. I want to make a few acknowledgments before we wrap up tonight. So firstly, to the team members, for all of your contribution and hard work throughout the school year. I really appreciate it, and this wouldn't be possible without you guys. And secondly, to Danny Sheridan, the founder and president of Wolverine Crypto Trading. Danny, it's been a heck of a journey this year from when we first started, and it's really your leadership, your mentorship, and your friendship that has allowed us to take this to new heights. So let's give him a round of applause. All right, guys, well, that's it. We'll stick around for a bit, but thank you all for coming out.